All right, you are welcome back to Introductory Mathematical Analysis. We are going to be doing this question in chapter 13. Chapter 13. So we are given this function y equals to x minus 1 all over x plus 1. And then we are asked to find where the function is increasing or decreasing. We are asked to find the relative maximum or minimum. We are asked to find where it is concave up and concave down. And then point of inflation, if any. Okay, so let's go with that and see. That is the function. So we have our y equals to x minus 1 all over x plus 1. X minus 1 all over x plus 1. Okay, so to find where it is increasing or decreasing, of course, the first thing is to derive, to find the derivative of this. So to derive that, that is quotient rule. Then we have derive the numerator, which will be 1, multiplied by the denominator, minus derive the denominator 1 also, then multiply by the numerator. Okay, all over x plus 1 square. Okay, so now we need to rewrite what is here. So this is x plus 1 minus x plus 1. Minus x plus 1, yeah? So x plus 1 square. Okay, x cancel x, so we are left with 2 all over x plus 1 square. Okay, that's our derivative. So now we need to equate the derivative to 0. Equate the derivative to 0. Okay, from what we see here, this implies that 2 over x plus 1 square equal to 0. We mean 2 equals to 0, which is not acceptable, is not correct, is wrong. So we can't go by this. Now that shows the next thing now is to check where the derivative will not exist. And of course, from the derivative, we have that the derivative will not exist where x equals to negative 1. The derivative will not exist. Okay, so we now have that the critical value is x equals to negative 1. Okay, so we use this now to find our interval. So it will now be negative infinity to negative 1. Then we have also negative infinity to positive 1. So that is our intervals. And then we want to know in this interval where the function is increasing or decreasing using our derivative. Okay, so if I pick any point between this interval, which is negative 2, if I pick any point here, I can pick 0 here. So I pick negative 2, and I put it in my derivative, to see what we are going to get, if it is positive or negative. Negative 2, so it will be 2 over negative 2 plus 1 square. All right, so that will be 2 over negative 1 square. And of course, that will be negative 1 square is 1. So it is 2. So that is positive. This is positive. So that shows that the function is increasing there. Okay, let's check on this one. Any point we pick there, that will be 0. If I put 0 there, that will be 1. 1 square is also 1. That will be 2. So that is still positive. So it's still increasing also. It's still increasing. So we see that the function is increasing on these intervals. Okay, 1, the function is increasing on that interval. Okay, on both intervals the function is increasing, so no decreasing intervals in the function, no decreasing intervals in the function. Okay, let me quickly check. Okay, relative maximum or minimum. Okay, so since there's no increasing, there's no decreasing and increasing, so that shows that we do not have the B1 now. So no relative maximum or minimum. Okay, they are both increasing. No relative maximum or minimum. Okay, that is that one. Then we need to find interval where it is concave up and concave down. Where it is concave up and concave down. So we need to find the second derivative. So we have our derivative to be 2 over x plus 1 square, 2 over x plus 1 square. Okay, I want to find the second derivative. Finding the second derivative of this, I can write this as 2 of x plus 1 square. I can write it negative 2. I can write it as that. So if I want to find the derivative, I'll just have negative 4 x plus 1, negative 3 multiplied by 1 to give us negative 4 over x plus 1 raised to power 3. Okay, that is our second derivative. Now again, we equate the second derivative to 0. We equate the second derivative to 0. So our second derivative, which is this, equate to 0. So we are going to be getting negative 4 over x plus 1, 3 equal to 0. We are going to get a scenario of this again, which is not possible. So again, what we look for here, it is where the derivative will not exist, okay, which is negative 1 also. So as s equals to negative 1, y prime prime will not exist. Okay, so we can use that negative 1 to find an interval. So we have an interval, negative this to negative 1, and then we have negative 1 to infinity. Okay, here we are testing for the second derivative to know where it is concave up or concave down. So this is the second derivative. So if I pick again here, if I pick again negative 2 and I put here, so I'm going to be getting negative 2 raised to power 3, negative 1 raised to power 3, that will be negative 4 over negative 1, which is 4. So that means the second derivative is positive here, and since it is positive there, that will be concave up. Okay, so let's test for this one. If I pick a point 0, I'm going to be having 1, negative, negative. So I'm going to have a negative there. If I have a negative there, that means it is concave down. It is concave down. So at this interval, at that interval, we have it is concave up, concave up, while at this interval, it is concave down. Okay, so concavity changes at negative 1. Negative 1 concavity changes. But if we look at the function given to us, let's look at the function given to us. If you look at the function given to us, -1 we make it undefined. -1 we make it undefined. Okay, so -1 is not part of the domain of the function. So though concavity changes at -1, but no inflection point there. No inflection point at -1, at x equals to -1, because -1 is not part of the domain. Is not part of the domain. So that is the D1. We don't have no inflection point. No inflection point. No inflection point. So no inflection point. Okay, please ensure that you understand what we did.